Tesla built a motor that spins at over 20,000 revolutions per minute inside a family car. Let me explain why that number matters so much, and why the engineers at rival companies who truly understand it are not sleeping well right now. Let me start with the basic problem every electric car company faces. It is not glamorous, but it is real. Electric motors have always forced a hard choice. You can build one that is fast and powerful, or you can build one that is efficient and gets good range. For decades, doing both at the same time was considered physically impossible. I am not exaggerating that. Engineers would sit in meetings and treat it as settled science. A powerful motor runs hot. A hot motor wastes energy. Wasted energy means shorter range. So you pick your priority and accept the trade-off. Every major automaker on the planet, Ford, GM, Toyota, Volkswagen, designed their electric vehicles inside that constraint. They optimized around the edges. They added bigger cooling systems. They added heavier batteries to compensate for efficiency losses. They called that progress. And to be fair, it was progress. Just not the kind that breaks the rule. It was the kind that works around it. Tesla refused to accept the rule. What they built instead is a drive unit, built around something that sounds almost too simple: a carbon fiber wrapped rotor. I want to explain exactly what that means, because the simplicity of the description hides how difficult the execution actually is. Inside every electric motor is a spinning part called the rotor. The faster it spins, the more force tries to pull it apart from the inside. Think of a wet towel being spun in the air. The faster you spin it, the more it wants to tear. At normal motor speeds, standard materials handle this fine. But Tesla's motor does not run at normal speeds. It runs at over 20,000 revolutions per minute. That is a speed you almost never see in anything designed for a road vehicle. That kind of speed belongs in aerospace equipment and industrial machines, not in a car you take to pick up groceries. At that speed, a conventional rotor would deform. It would shed material. It would heat up so fast, it would destroy itself. So Tesla wrapped the rotor in carbon fiber. Carbon fiber is the same material used in fighter jets and Formula One cars. It is incredibly strong and incredibly light at the same time. The wrap holds the rotor together under forces that would wreck anything else. It acts like a precision shell, like armor that weighs almost nothing. What this unlocks is remarkable. The motor now runs stable at speeds nobody else is running. That stability sharpens the magnetic efficiency inside the motor. More of the electrical energy coming from the battery turns into actual forward motion. Less of it leaks away as heat, noise, or vibration. In a normal motor, a meaningful chunk of the energy you pull from the battery is simply wasted. Tesla's design recovers most of that waste. Same battery, more range, more speed, less heat, and that last part, less heat, matters more than most people realize. When a motor runs cooler, you need less cooling equipment around it. That means fewer pumps, fewer coolant lines, less weight, less complexity, fewer parts that can break, Every competing company right now is bolting heavy cooling systems onto their motors just to keep them from destroying themselves. Tesla quietly designed away most of that problem. The downstream effects pile up fast. A lighter, cooler, more efficient motor means the whole car can be lighter. A lighter car needs a smaller battery to hit the same range target. A smaller battery costs less money. Less money means a lower price to the buyer. Every gain feeds the next one. The real-world result was the Tesla Model S Plaid. 3 of these motors working together, over 1,000 horsepower, 0 to 60 miles per hour in under 2 seconds. That figure is almost hard to process. For almost all of automotive history, a car doing 0 to 60 in under 2 seconds was a race car, a machine built by hand for a professional driver on a closed track. The Plaid does it in a 4-door sedan you can buy and drive your family around in. And it does it while also being one of the more efficient luxury electric cars on the market. What I find honestly stunning about this is that those two things, brutal acceleration and high efficiency, were supposed to be opposites. Tesla built one machine that does both simultaneously. Now here is where it gets genuinely uncomfortable for the competition. You might think, okay, Tesla figured this out. Now everyone copies it and catches up. That is not how this works. The carbon fiber wrapping process is one of the hardest manufacturing challenges in the industry right now. The carbon fiber arrives as a delicate tape that has to be wound around the rotor under exact, consistent tension. Not approximately right, exactly right. If it is wound even slightly too loose, the rotor flexes at high speed and fails. If it is wound slightly too tight, the fibers crack during curing. After winding, the component goes through a controlled heat and pressure process to cure the material into a single solid shell. The temperature has to be precise. The timing has to be precise. Miss either and the rotor is scrap. And then each finished rotor has to be balanced to tolerances most factories never deal with, because at 20,000 revolutions per minute, a vibration that would be invisible at highway speed becomes a violent, self-destroying force. What I understand from this is that a competitor cannot just look at a Tesla motor and build one. They have to rebuild the entire manufacturing process around it. Every mistake costs money. Every failed rotor is thrown away. Every small adjustment takes months to test and verify. This is years of painful, expensive, unglamorous work that Tesla already paid for. Competitors are only now opening that bill, and Tesla is not standing still while they do it. The company has publicly stated that its next-generation drive units are being engineered not just for performance, but for manufacturability. The goal is to produce the complete drive unit, motor, power electronics, gearbox, for around $1,000. Some competitors currently spend 3 to 5 times that amount to build something with comparable performance. Think about what that gap means at scale. If a rival spends $4,000 per drive unit and Tesla spends $1,000, and both companies ship 500,000 vehicles in a year, Tesla keeps $2 billion that the rival does not. That money funds the next generation of research, while the competitor is still trying to reach profitability on the current one. Tesla is also working to remove rare earth materials from its motors. Rare earth elements are expensive, and the supply chain for them is heavily tied to a small number of countries, which creates risk. Tesla is simultaneously redesigning its power electronics to reduce dependence on expensive silicon carbide semiconductors. One by one, they are cutting out the points where outside suppliers can squeeze them. Rivals are still being squeezed by most of those same points. Let me be direct about the competitive landscape, because I think it is widely misunderstood. The electric vehicle space is already full of companies that built great prototypes, attracted huge investment, and then came apart when real production at scale arrived. Ford built genuinely capable electric trucks and cars, and still lost enormous amounts of money on each one. Ford has more than a century of manufacturing experience and still could not make the numbers work. Lucid built technically impressive luxury EVs and kept burning capital. Rivian attracted billions in investment and struggled badly with production costs. General Motors and Volkswagen have both had significant delays and software problems with their electric lineups. What I see in all of this is that the difficulty is not designing a good electric vehicle. The difficulty is producing millions of them consistently at prices buyers can afford while generating profit. That is where most companies fail. And Tesla has been grinding through that problem for years while everyone else was still in the design phase. The only company that currently looks capable of competing with Tesla at true global scale is BYD. And I want to be clear about what BYD's advantage actually is. BYD's strength is affordability. They flood markets with high volumes of lower-cost vehicles. That is a real and serious competitive advantage. But it is a different game than what Tesla is playing. Tesla is trying to build the most technologically advanced electric vehicles on Earth and also make them cheaper to produce than anything comparable. Cheap is achievable. Cheap plus fast, plus efficient, plus genuinely desirable all at once is where almost nobody else currently operates. Now, here is the part of this I find most important. And it is the part most people miss entirely when they think about Tesla. The motor is not just a motor. It is the piece of hardware that funds and powers a much larger system. Every time Tesla makes its drive unit cheaper to produce, it can sell more vehicles. Every additional vehicle on the road is a sensor. It collects driving data constantly. Road conditions, driver behavior, weather, traffic patterns, rare situations that only appear after millions of hours of real driving. That data trains Tesla's autonomous driving systems. Those systems improve the way a human driver improves, through experience. And Tesla has accumulated more real-world driving data than almost any other company on the planet. The connection between the motor and the data is direct. A cheaper motor means more affordable cars. More affordable cars reach more buyers. More buyers put more vehicles on the road. More vehicles collect more data faster. More data trains smarter systems faster. Smarter systems increase the value of every Tesla already in existence. Higher value draws in more buyers. The loop closes on itself and accelerates with each rotation. A late competitor does not just have less data. They pay full price for every lesson Tesla absorbed years ago. Tesla also designs its own chips, its own software, its own vehicle control systems, and a significant portion of its own computing infrastructure. It built the Dojo supercomputer specifically to train AI on the driving video its fleet collects. Most rivals rent computing power from NVIDIA, Amazon, Google, or Microsoft. Tesla chose to build its own because the company believes the future is less about the cars it sells today and more about the intelligence those cars can operate tomorrow. The semiconductor shortage that paralyzed the auto industry a few years back showed this difference clearly. When chips became unavailable, traditional automakers stopped production. Tesla rewrote its software to work on the chips it could actually get, and kept building. That one moment revealed something fundamental. Tesla behaves like a technology company that manufactures cars. When conditions broke, car companies stalled. The technology company adapted. The factory network makes the same point. Plants in California, Shanghai, Berlin, and Texas form a global production base. Future facilities in additional markets could push costs further down. Every one of those plants is being set up to produce that $1,000 drive unit at massive scale. This is not a lab achievement sitting in a presentation. It is being woven directly into Tesla's global industrial infrastructure right now. The charging network is part of this too, and I think it is still underestimated. Tesla's supercharger network is fast, reliable, and widely available. Competing networks have struggled badly with broken hardware, confusing payment systems, and incompatible plugs. Charging became the part of electric car ownership that people feared unless they drove a Tesla. The competition eventually conceded. Ford and GM adopted Tesla's charging standard so their own customers could access Tesla's infrastructure. Their customers now depend on Tesla's network to charge their non-Tesla cars. And Tesla earns revenue every time they do. That is not competition. That is one company's infrastructure becoming the foundation everybody else relies on. What I understand now, after looking at all of this together, is that the motor is the door. Everything else walks through it. A better motor makes more vehicles possible. More vehicles generate more data. More data builds smarter software. Smarter software increases the value of every Tesla on the road. Higher value funds, better hardware. Better hardware produces the next, harder-to-beat version of the motor. The companies watching this most carefully are not just worried about falling behind on one product. They are worried about falling behind on the foundation every future product gets built on. You cannot buy your way around that. You cannot license it. You have to rebuild it from scratch, while Tesla is already years ahead in manufacturing practice and scaling capacity. And by the time the rebuild is finished, Tesla has moved the target again. That is what I think this motor actually represents. Not a single, impressive engineering achievement. A signal that the rules the whole industry agreed to follow no longer apply. The trade-off everyone accepted as permanent has been broken, and the company that broke it also happens to control the battery supply chain, the software, the charging network, the manufacturing infrastructure, the driving data, and the AI compute, all feeding each other, all accelerating together. For me, the main thing is this. The motor got all the attention, but the real breakthrough is what the motor makes possible across every other layer of the system. That is what makes this so hard to compete with. And that is what I think the smartest people in the industry are actually losing sleep over.